Right.
We'll go ahead and start it up.
All right. I'm honored to be joined today by Dr. Ogi Ogas. He's a computational neuroscientist, an expert in consciousness and human sexuality, and author of A Billion Wicked Thoughts, which we'll be talking about today. Ogi, welcome to the Nature and Nurture podcast.
Thanks for having me, Adam. I'm excited to be here.
So I want to spend a lot of time talking about your book, A Billion Wicked Thoughts and Human Sexuality, but I know you've done a lot of other writing on consciousness and on autism, being autistic yourself, and writing about not only the personal side to it, but the computational neuroscience perspective on what's actually happening in differences in social cognition between autistic and non-autistic individuals. And I've been maybe at a fuzzy border between the two because I certainly have some social difficulties. I don't think quite as much. So that's why I seem to like the framing of this as a spectrum disorder. Although I know you have some hesitation with that
Yes.
terminology.
Yes. Let me just back up and give the 30,000-foot picture of who I am and what I'm bringing to the table with regard to minds and brains. So I, I would consider myself a mathematical neuroscientist rather than a computational neuroscientist. And why does this matter? It's because the notion of computation connects us with computers and it connects us with digital technology. And in particular, these days, it connects us with digital AI. And so when people think about the mind and the brain in neuroscience, it's people's tendency to connect it with AI. And they imagine that the AI that's getting so powerful these days is rivaling the human brain or is connected to the human brain. But the algorithms, the technology, the math behind artificial intelligence is completely different than the math and the physical dynamics in the brain. They're completely separate. What's happening in our brain is not computational. It's dynamic. It's a different math. It's different physical dynamics. It's just a fundamentally different physical phenomenon. So that's why I don't like to be called computational, because originally the term computational neuroscience, it kind of arose with this idea that we'd figure out all the algorithms of the brain, but the brain doesn't run on algorithms, it's not digital algorithms like AI does. So uh,
Mhm.
I look at
Can I
all of
push
these
back on that?
questions. Oh, go ahead.
Well, I think I might use computational too liberally, and some people tell me this about my definition of consciousness as well. I'm really sympathetic to these ideas. It's kind of related to the simulation hypothesis of the universe, but that everything is math, that everything is computation. And this overlaps well with panpsychism. So if you say that consciousness is fundamentally information processing, everything is in the universe is doing that, whether it's on silicon, whether it's in our brains, whether it's just at the basic particle level. You can think of even quantum fluctuations, spin up, spin down, almost like a binary transistor or a binary bit of information. And to me, this overlaps nicely with metaphysics like Spinoza, who had this idea of God as nature, God as the set of all natural laws. So those are a lot of priors that I'm coming into the conversation with. And I seem to use computation not so much in the more recent past 70 years digital computation, but more like this broadest sense where I use it often interchangeably with mathematics or information processing.
So that I certainly understand that. I would say that's half the universe. That's the digital universe. That's the zeros and ones universe. That's the integers. That's discrete mathematics. That's certainly a useful way of thinking about reality if you're studying aimless activity like physics, if you're studying the dynamics of aimlessness, purposelessness. But the moment you bring purpose in, the math changes. You know, now you're using reals. Now you're using dynamics instead of algorithms. So yeah, our brain doesn't work on algorithms. Our brain doesn't work on zeros and ones. So information theory, you said the whole universe is information theory. Again, half the universe, the, a digital perspective, an aimless perspective, a mechanistic, machine perspective. But our minds are capable of more than that. With the information theory perspective, based in Claude Shannon's notions of zeros and ones communication. Uh, a piece of information is either zero or one. That's it. But when you're dealing with minds, and the dynamics of purpose, and why I consider myself a mathematical neuroscientist, is because the brain can hold states that are 0 or 1 or 1/2 or both at the same time or blue. There's no limit. There's no mathematical constraints on what the mind can produce, what purpose can produce. It's just different system, different activity, um, a different physical flow. And so
Have you followed Carl Friston's active inference theory of consciousness?
I know the basics. I'm not deep into Friston. I certainly know Friston and his work, and I know the basics of that. Yes.
Is that compatible with how you think of it in these mathematical terms?
So here's my position on the brain and mind and consciousness and thinking and sexuality and everything to do, feeling, uh, language, self awareness. So there's three mathematical approaches to the brain these days in the 21st century. Two are famous and dominant and wrong, and the others less well known and correct. And this is the story of mind science over the past 400 years, especially over the past 100 years. The story of mind science is there was no math until the 21st century. The huge turning point in the history of mind science, most mind scientists, neuroscientists don't know this, was Sigmund Freud in 1895. In 1895, Sigmund Freud published Project for Scientific Psychology, and he figured out the correct mathematics for modeling the brain, dynamic math. He modeled a neural network mathematically. It was exactly the right track. It was exactly the way to go. 60 years later, Stephen Grossberg would pick up the work and do it correctly. But Sigmund Freud actually was staring at the right math to understand the brain in 1895. But then he had young women on his sofa talking about sex, and he thought that was way more interesting. He abandoned all of the math and he went the exact opposite direction. He became anti-math and he ruined mind science and neuroscience for the next 100 years, rejected math. And so throughout the 20th century, mind scientists, psychologists, neuroscientists thought you don't really need math to understand the brain. When I was in psychology as an undergraduate in the 90s, and then a grad student, nobody was studying math. Math was for the physics. For the mind, it's just a qualitative and categorical. It changed in the 21st century, unfortunately, because we had this long history of mathlessness. Bad math snuck in. What is the bad math? The first mathematical approach is statistical math, looking at the brain as a Bayesian processors, probabilities, and statistics. This is a very old tradition, originated from astronomy, not from studying brains. So this is a mathematics designed to study other physical phenomena, aimless phenomena, not the correct math for studying the brain and neural dynamics and the dynamics of purpose. But so many people have been trained in statistics. So many people, you can study just about any field of science and get some statistics background. So everybody knows some statistics. So they think, oh, I'll just bring this math I already know that I've learned somewhere else and apply it to the brain. That's not the way to go. The other mathematics applied to the brain is what you mentioned, information technology, rooted in Claude Shannon, algorithms, zeros and ones, stopping theory, Turing's theory, all of these discrete math theories also applied to the brain. A lot of people take the information technology approach. Sounds like you do as well. This math was designed, 100 years ago. Turing helped devise it. It wasn't for studying brains. It was coming out of discrete math. It was coming out of algorithmic theory, not something to do with brains or neuroscience, neurodynamics, biological intelligence. Wrong kind of math to study that stuff. What is the right kind of math to study the brain? Sigmund Freud first hit it in 1895. Stephen Grossberg in 1958 picked up on it, and he's been doing it nonstop for more than 65 years now. Dynamics, dynamic math. The mind is activity. The word mind is an action noun. So consciousness, activity, our sexuality, activity, perception, feeling, all of this is activity, not zeros and ones, not probabilities and statistics. It's activity. It's like the flow of the ocean, or it's like the flow of wind over sand dunes. That's what's happening in our mind. And that's the correct math. And once you apply that math, everything opens up. Everything fits together. Consciousness falls out. Language falls out. Self-awareness falls out. All of this, once you apply the right math, it all makes sense and it all hangs together. There's a reason why discoveries in neuroscience and mind science are few and far between. It's because everybody's using the wrong math, the wrong methodologies, the wrong mental conception of what's actually happening in the brain. And I apologize for that very long-winded rant.
Do you see these things as nested or compatible at all? Because I see some merit in all of them. You know, the dynamical systems approach, I'm more familiar with talking about cellular level dynamics and just noise and random fluctuation in brain signal. But then once you go to a more macroscopic level, it does seem like the more algorithmic neural networks approach works well. And somewhere in between those, the Bayesian statistical learning approach, when you're talking about, you know, updating and Hebbian learning, like cementing statistically, like somewhere between that more dynamic systems, lower level of analysis, and before you get something that you can say this is a neural network optimized for this particular function, somewhere along that you get this sort of statistical Bayesian learning of well, that seems to be the right way to think about plasticity for me.
That's the right way to design computer algorithms that are doing data mining or AI or you can create a neural network as a digital algorithm to do data mining, but that's not modeling the brain. That's just performing some kind of data mining function, whatever you want. You can certainly create algorithms to do that, but that's not going to be any kind of biological model.
Mhm. Have you heard of Mark Solms?
No, I have not.
I think you'd like Solms's work, and he has a book called The Hidden Spring, talking about a computational theory of consciousness. Now, Solms is a collaborator of Friston's, so he's in on the active inference, information theory of mind, and Bayesian processing, but he's also trained as a psychoanalyst, and he's an expert on Freud. He's just written a new translation of um, what's it called when you compile all of someone's work together into one big book?
I don't know. Anthology?
Yeah, he's just worked on an anthology of Freud's, and he's trying to revitalize this project for a scientific psychology in these computational
Oh,
neuroscientist terms. Now, maybe the caveat for you is that he's doing it more so from a Friston computational perspective, but I think there's a lot of overlap. Now, what sold me on the Bayesian interpretation in particular is he's a psychoanalyst and he's also trained as a neuropsychologist studying brain damage. And he talks about confabulation. So whether that's split brain patients, you know, the left hemisphere operating language, trying to make up a story for what the other side of the body is doing, or whether that's people with uh, more limited types of aphasia. So he's talked about patients who I think because of aphasia in terms of recognizing faces, they'll go to the doctor's office. They have this vague sense of familiarity, recognizing Mark Solms, the neuropsychologist, but they can't pinpoint it. They don't have the right memory of, oh, you're my doctor. So they just have this vague sense of familiarity that's maybe in more bottom up emotional regions. And then they try to confabulate some sort of story, like, did we go to high school together? Whatever the thing is. And he brings a Bayesian framework there saying that when you have this type of aphasia and the rest of the brain is working as an interconnected network and you just have essentially one node dropped out, the rational Bayesian thing to do is say, given all of this, what is the most probable outcome? Now that maybe you can explain that in the dynamical systems framework as well, but I'm not as familiar with that.
yeah. I mean, this is the problem is that everybody knows statistics. It's pretty easy. You can learn it as an undergrad, but the actual math to describe the brain's really hard. And it takes a lot of effort to learn it and understand it. And nobody wants to do that. So they keep using bad math that doesn't have anything to do with the brain. The brain's not Bayesian. So what I always recommend is just understand how consciousness works. There's no Bayesian explanation of consciousness. There's no information technology explanation of consciousness, no digital algorithm explanation of consciousness. The only way you can understand consciousness is through dynamic systems, as activity, as flow, as things changing, growing and decaying. That's the way to think of mental activity. And consciousness can only be understood through a dynamic processes. And once you see how consciousness is working in the mind, everything else makes sense because everything else is flowing into consciousness or flowing out of consciousness.
Uh-huh.
Yeah, there's no
Okay, well,
Bayesian explanation of consciousness. I can explain consciousness to you. It's not even that hard. It's not hard to understand the basic operation of it. It's just the math and the mathematical detail is very difficult. But the way the consciousness works, I will explain it to you in less than 5 minutes. Our brain has different modules. A module is a set of neural networks that have come together for a particular purpose. For example, one of our uh, the modules we use the most is the visual what module. It identifies what we're looking at. I'm looking at my hands. My visual what module just identified my hands. We have a visual where module. It identifies where an object is we're looking at. Oh, my hand is over my head. Oh, my hand is below my head. There's an audio what module, identifies what something is from the sound, an audio where module. There is a why module. That's how we have conscious emotion. Why should I do this? I'm hungry, so I'm going to go to the restaurant. I am sad, so I am going to sit here and cry. The why module handles that. So we have all these modules, and a number of these modules are able to produce consciousness on its own. So this is a first fundamental truth about consciousness. There's not one place in the brain where consciousness happens. There's many modules that are capable of producing consciousness. How do you know if a module is capable of producing consciousness? It has top-down, bottom-up resonance. Resonance is the physical activity, the physical dynamic that embodies consciousness, that embodies the conscious experience. Whenever you are saying, I am conscious, whenever you're experiencing, I am aware, there is resonance in one or more modules in your brain. Resonance is between top-down and bottom-up. It's resonance between an expectation. What do I think I'm going to see? And reality, what I'm actually seeing. So we expect to see something. I expect to see my hand because I'm holding up my hand in front of my face. I see my hand. The reality matches expectation. There's a resonance in the visual module. I recognize my hand. Top-down expectation matches bottom-up reality. And then I'm aware of the hand. Now that when a resonance occurs, it tries to get the rest of the brain to resonate too. So let's say I'm looking at my hand, it's resonating. Top-down, bottom-up match, expectations matching reality in my visual what module. Now that visual what module tries to resonate with the other modules. It tries to get the visual where module to resonate. Hey, look at the hand. It gets the audio module. Hey, is the hand making any sound? And if it succeeds, it'll get all of the modules in the brain to resonate together. And then you're conscious of all the details of the object. In this case, the hand. I can hear it. I can smell it. I can reach out and touch it. All of these things doing together. So what happens in our brain, inputs always coming in to our modules. Each of our modules is processing inputs in parallel. So my audio modules are doing their thing the same time my visual modules are doing their thing the same time my Y modules feeling things. And at any moment, if one of them thinks something's very urgent, oh, I hear the sound of police sirens down the road. That module will then try to resonate and get its resonance to resonate with the rest of the modules in your brain and get them all to synchronize and focus on the same thing at the same time. And so that's why, for example, watching a movie is a more immersive experience than, say, looking at a painting. When we watch a movie, we have many more modules resonating together and giving us a conscious experience. We're seeing it. We're seeing the locations of things on the screen. We're hearing it as well. We're having feelings. When we're looking at a painting, fewer modules, so it's a less immersive experience. And this applies to everything. The more modules that are involved, the more different conscious resonances are happening in our brain, and the more immersive the experience it is. So that's consciousness, 5 minutes or less.
Right. So I studied cognitive science and biostatistics, and I'm still pretty early in my training. And as you mentioned, there's this deep-rooted paradigm now of either the information processing influence or the statistical influence. So that's what I'm coming at this from. And
Sure,
when
I
I
know.
push back, I'm really trying to make sense of it, given what I've
Yes.
been told, more so than trying to say this one is right. But
Yes.
that sounds quite similar to the way Friston talks about prediction error, this resonance that you're talking about. And also when we're talking about, say, a movie is more dynamic than a painting, in the information theory sense, that also seems to say, well, it just contains more information in this integrated information theory way. So what I like is that I agree with everything you're saying. What I'm confused by is that it sounds like you're saying that these two theories or the different mathematical systems are at odds with each other, but
Yes.
that's the part I'm struggling to see.
So statistics is aggregate math. It's a math of aggregation. Look at all the items in a collection, and you calculate statistics. You summarize them. There's an average, there's a median, there's standard deviation. But in the brain, there's not some, it's not like there's not a statistics calculator module that's constantly calculating the statistics of visual stuff or the statistics of audio stuff. It's just a whole bunch of different agents in your brain reacting to things all at the same time. So there's no, like, things aren't sent to a statistics processor who processes some statistics and then send it out somewhere else. It's just kind of, it's like players in a basketball game. That's the metaphor I usually use. Like a really good metaphor for understanding how the brain works is five players in a basketball team trying to score against five players on another basketball team. Each one is operating in real time, making decisions and interacting with each other in real time. Where's the ball? Where's the other players? How am I going to pass it? You, you can describe a basketball game statistically. You can say there were X many jump shots. There was this many points scored, this out of this many shots. It was this percentage accuracy. And you're summarizing the basketball game, but you can't take that set of data and predict the flow or the operation or the activity of a new game. Like, you can't look at the statistics that result from a game and guess, okay, here's going to be another game. Where will I find this player? When will these players score? How will these players decide to score? Like, those questions can't get answered by this statistical analysis. But if you understand things like, okay, when they're on offense, they have a superstar. They're going to try to pass it to that superstar. That's more of a dynamic description of the game. And wherever the players find themselves, they're going to pass it to the superstar wherever he is on the floor. That's more of a dynamic understanding of the game. And it gives you a better sense of how the game is going to flow and how the players are going to perform. If you just say they have a star player and he gets the basketball 30% of the time, might be an accurate summary, but it's not really going to help you understand the moment to moment flow of the game and the activity of the game and the action of the game.
What about visual tuning curves where, say, you have a neuron that's optimized for firing in response to a vertical line stimulus, but if the line is 80% straight, it fires at 80% the rate, and it's a gradual decrease until it's not really responding, or it's responding just random noise to a horizontal line. That seems to be more fundamentally statistical, but also I agree with you that it's dynamic because you're constantly getting new photons and it's constantly well, we're not even talking about binary, does it fire or not? We're talking about a firing rate, and whatever the minimal rate would be is just noise driven. And then there's some maximal rate, and there seems to be this dynamic tuning between that. Maybe what's missing is people talk about it conceptually, as in, well, this is a probabilistic response, but you're saying that that's right conceptually, but the math itself, it's not a simple Bayesian formula.
Adam, great example. Let me run with what you just said. Great example to illustrate all of this. It also shows why mind scientists just get caught up in things that are not always helpful for understanding the brain, but they're easy to do methodologically. So you're right. There are neurons that respond to the angle of a line, for example. The strength of the firing depends on the angle of the line, just like you said. And that's something easy to measure. We can find an individual neuron and we can figure out exactly the angle of light that we show on it. And we can figure out how often it fires. These are easy things to measure. And when you've got something easy to measure, that the temptation is just to do all kinds of, simple math on it, like statistical analysis. But here's how a dynamic approach would take this that separates it from the statistical approach. Yes, there is a neuron that responds differently to different angles of light. Here's the question. What system, what network, what flow would you put such a neuron in? What neurons are going to lead into that neuron? What neurons are you going to take to have that signal go out to? Are you going to have a bunch of those in parallel? Are you going to have a bunch of them in series? What matters is how you take that one neuron and put it together with a whole bunch of neurons to create a new system. And maybe you're not going to be able to predict that what that system is going to do just from knowing a single neuron in it. Here's another way of looking at it. I'm going to go back to my basketball metaphor. You know, there's a basketball player. If he's in the middle of the court, he shoots 50% of the time. If he's next to the basket, he shoots 80% of the time. If he's far from the basket, he shoots 20% of the time. You can have the same kind of statistical relationship on a basketball player and shooting that you have on a neuron. So the question, though, then becomes, where do you put that basketball player? Do you have him near the basket, away from the basket, or do you have it dynamic? Do you have it near the basket when the other team's doing this, and then away from the basket if the team's doing that? Now you've got something contingent. The brain is always working on contingencies. But if you're just focusing on the statistics of this one neuron and how it responds, you're going to lose sight of the bigger picture of how this neuron is designed to play in a larger system. Just like how a basketball player, you can put the basketball player here or there. You can have him play a pick and roll. You can have him passing back and forth. You can have him do all kinds of things, even though he's still a 50% shooter, for example. Just like there's a neuron that responds to lines this way, 50%. Yeah, you know facts about that. You can calculate statistics about it. But what matters is the flow. It's the system. How you put that one piece in with a lot of other pieces that are all doing little statistical things, and you get a flow out of it, and you can get complexity that can't be reduced to simple statistical functions.
When you have this dynamic flow, why then does the brain specialize into modules? You know, we could, to use the basketball analogy, well, there's going to be different roles that you could be point guard or whatever, but you could also say, well, it's just so dynamic that you just have players and player takes on whatever role given the context is most probable to score. This seems like the plasticity versus specialization trade-off that we see across development as you get, pruning and increases in myelination.
So the reason it's difficult to use statistics to predict what's going to happen is the same way it's difficult to use statistics to predict a basketball game. The point is, every player, just like every neuron, is an individual agent. It's got its own mind. In fact, to understand the human brain, it's important to understand there's 4 distinct levels of thinking, 4 distinct layers of thinking, 4 distinct layers of mental processing, all happening at the same time. This is another tremendous source of confusion among professional neuroscientists and mind scientists. We're so used to just thinking of neurons like there's a neuron level. That's the level that's happening. But no, that's not the case. So the bottom level of thinking, the simplest purposeful activity in the universe, is molecular thinking. This is what we find in the minds of bacteria, archaea, which is the oldest and smallest creatures on Earth, and protozoa, single-celled creatures. They've got minds. They have perception. They plan. They have memory. They take action. They have a mind. The mind is made of molecules. We can count them. We can identify them. We know the exact molecules, say, in an amoeba that allow it to think. Molecular thinking. But then these molecular minds came together to form neural minds. The simplest invertebrates, jellyfish, worms, insects, they have minds too. Their minds are collections of neurons, but each neuron is a self-contained mind. Each neuron is a molecule mind. So now we have a hierarchy. In a jellyfish is thinking through neurons, neuron to neuron communication, neuron to neuron thinking, but each neuron is its own agent. Each neuron is like a basketball player. It's got its own mind, its own molecular thinking. It's making its own decisions, even though it's part of a network. And now that network has a goal, an aim, a purpose. For example, jellyfish has a network that just squeezes and makes the jellyfish go forward. It propels the jellyfish forward by squeezing. Basically, all the neurons fire at the same time, squeezes, the jellyfish goes forward. It has a purpose, this network of neurons. But if you take any individual neuron, that's a single-celled molecular mind. And all it cares about is, I'm going to take some inputs and I'm going to fire. It doesn't know that it's part of a network. It just knows, give me this input and here's my output. And the same for the network. Now the network takes an input. The network takes a network input. What is the status of where I am in the environment. Should I squeeze? Is it time to squeeze or not? So it's got two layers of thinking happening simultaneously. Then in animals, vertebrates, fish, amphibians, birds, reptiles, all mammals except for one, all mammals except for us, they all have module minds. Networks of neurons come together to form modules like the visual what module. So in the visual what module, it's taking as a modular input. What am I looking at? I see a visual pattern in front of me. That's the input to the visual module. But inside the module are networks. Each network is its own network mind, doing its own thing. There's a network, for example, that just creates expectations. I'm a network in the visual what module, and my purpose is to generate expectations for what this module might see. But in that network are individual neurons, and each of them is doing its own thing. So there's three levels of thinking all happening simultaneously in every animal brain, in our brains too. There's molecular minds within the neurons. There's neural network minds at the neural level, and then there's a module mind above that. On Earth, only one species has gotten to the fourth level of the ladder of purpose, has gotten four layers of thinking. That's us, human beings. We've got super minds. Each brain is like a neuron in the network of the supermind. Our brains, well, I should say non-autistic brains, all non-autistic brains are designed to be network hubs in a network of other brains. Or the way the human brain is designed to function, to perceive, to remember, to know, to think, to act, to choose, to decide. All of this is designed to operate in conjunction with other brains, just like our network. Our neuron activity is designed to work with other neurons. And we're the only creatures on Earth that have risen to this level yet. If you're autistic, then the tribal circuitry doesn't work so good. The supermind circuitry doesn't work so good. And so we're closer to individual module minds, those of us with autism.
Wouldn't you say that other primates do this to a lesser degree, and even in radically different ways, other hive mind species like insects? I know they would be bypassing, they'd go straight from these simple neural networks up to hive mind. There's not going to be the modular consciousness in between at the level of an individual bee. But when you make absolute statements like humans are unique in this way, I view it more like this is a continuum of computational complexity. And yes, we're at the pinnacle as far as we know, but it doesn't seem like it's a fundamentally different computation.
No, it fundamentally is. So that's the point. It's not a continuum. A new layer gets built on top of the other layer, and both layers are operating simultaneously and discretely. I mean, they're interdependent. What's happening in the neurons filters up to the next level. What's happening in the next level filters down. But this is very much part of the dynamic design of the brain. This is very, very much part of the fundamental structure of biological intelligence, is this use of these layers. This is what gives us self-awareness. We are the only creatures on Earth capable of self-awareness. Why? Because we're the only creatures on Earth with this fourth layer of thinking activity. You need a separate layer of activity on top of the consciousness activity in order to have self-awareness. So chimpanzees and frogs and toads and snakes and fish, they're all conscious, they're all aware, but they're not self-aware. You can help primates, you can create a fake fourth layer in primates if you put a mirror in front of them. So kind of famous, there's a primate dot experiment, and you paint a dot on a chimpanzee's head and looks in the mirror, and after a while realizes, oh, that's me. It's creating a self-aware loop through the mirror. But what we've done, what human beings have evolved, is we've created a mirror inside our brain. We've created a new layer on top of this conscious dynamics. I talked about this conscious dynamics, that we've got this layer of modules, and a module will resonate and try to get the other modules to resonate. That's consciousness. All the animals have that. We have an additional module, language module. Actually, it's a language. It's a set of language modules. It's not as simple as a single module, but that's on top of our consciousness system. So humans have a system on top of the consciousness system that interacts with it, that provides us with both language and self-awareness. This is what the supermind does. The supermind gives us language, and the supermind gives us self-awareness. It takes a society to have a self. You can't have a sense of self, a sense of me, I, the word I, using the pronoun, unless you have a sophisticated enough society. And it must be sophisticated enough. Through most of human history, we didn't have sophisticated enough societies to generate self-awareness or selves.
I'm thinking that the way that chimpanzees represent social hierarchies, being deeply hierarchical, that that's sort of this fourth level of social cognition, and they must be able to know where they rank. And that seems to be a level of this introspection theory of mind.
Yes, that definitely social hierarchies like alpha males. Um, these are social dynamics, but they in chimpanzees, it doesn't rise to the level of a supermind because they're able to track individuals, certainly, but so do all conscious minds. I mean, even fish are able to track individuals. Some fish are able to track individuals. Like I know this fish from the past. This fish is, I've mated with this fish, or this fish is friendly, or this fish is not friendly. Um, so this is with it. All you need for that is a sophisticated enough what module to track an individual and know who that individual is. But for superminds, what separates us from those primate hierarchies is language, is the fact that we have a shared understanding of meaning that's distributed across multiple brains. You know, chimpanzees don't have language. They don't point. Pointing is another fundamental element of supermind dynamic. Supermind thinking is being able to point and view the point. If you point in front of a chimp, it looks at your finger. It doesn't know to follow it. And
I
it's
thought they
very,
do
very, very
point at threats, and also even dogs can follow human pointing.
dogs can follow pointing. I believe that's true.
Mhm. So that's why I'm tempted to look at all of this as, yes, humans are doing it at a much more complex way, but it's the same computational mechanisms. And also theory of mind tasks. There's a lot of interesting overlap between introspection and theory of mind, just same default mode networks of the brain that operate on that. And chimps, like young toddlers, can pass these pretty basic theory of mind tests. Like, the ones about puppets, and you're hiding something in the box and one puppet goes away, and you measure by looking time. Is the infant surprised or not if the puppet lacks or has knowledge of this thing that they just observed? You have to make it in a way that animals can follow these, but a lot of animals, even birds, seem to demonstrate that level of awareness. And that makes me think, no, like backwards level thinking, knowing that theory of mind and introspection seem to rely on fundamentally the same circuits. And if animals can do theory of mind, then they must have a proportionate amount of introspection.
So theory of mind is sort of an ambiguous concept. It was developed in the 90s as an explanation for autism, where it never made any progress. Uh, I had a friend in the 90s that did a lot of that theory of mind research with adults and the kids. I remember it well. That was also when I
Mhm.
was first learning about autism. But it's it's a concept that was proposed in the 90s that wasn't grounded in any kind of neural dynamics. It was a notion proposed that tried to explain the fundamental challenge of autistic people. And it kind of made sense intuitively. It looks like autistic people have trouble with other people's minds, but that's not really what's going on. And it's also never been articulated in a biological way that makes sense. I mean, what neural systems do you think it's rooted in?
Autism?
No, theory of mind.
It seems kind of like a chicken and egg problem because I know that there's a deep parallel with introspection, but I don't know if it's better to think about theory of mind as you're first imagining yourself in someone else's shoes and then introspecting from that position, or if it makes more sense to say theory of mind evolved first and introspection is really taking a detached view of yourself and then applying social cognition on that.
So these are kind of psychological or behavioral analyses. We're sitting on the outside looking at behavior that looks like theory of mind behavior and guessing what could be the neural basis. But at some point, you've got to ground it in a neural system. And I mean, it's got to be in a module. I mean,
Uh-huh.
if there
Okay,
is
I
theory of
could take
mind,
a more direct stab at it.
you've got to explain. Here's the dynamics. It's this brain system, like the visual what modules communicating with the how module, or whatever, whatever systems you think, you've got to be able to ground it. And there doesn't seem to be a need for such a system that we can explain everything around it without having a need for like a separate theory of mind system. I mean,
Uh-huh.
that's why I've always
So
been
I wonder
dubious,
if it's
found it a
deeply
dubious
related
concept.
to interoception and also kind of related to how people experience phantom limb syndrome, as in not only are we representing parts of ourself, but you can even get a false read. And then this is kind of related to the philosophy of mind idea of the extended mind. And I think driving a car is an interesting example. I don't know if others experience this, but driving it's almost like I fear experience this temporary embodiment with the car. Like it's almost like you can sense the boundaries, and instead of thinking, if you get hit, you're not really paying attention to receptors on your arm. It's almost like you can feel it. So, even just if you accidentally scraped by something, it's like, I mean, you don't physically feel it, but you sort of feel it in this indirect way. And I wonder if it's the same way that we indirectly represent the social environment. Does that make sense?
No. So when we're driving a car or operating, so we're actually using modules that are unconscious. So the, the part of our brain that's does targeting towards an object. So if you're driving, that's targeting towards an object. I'm going to drive down the center of the road. I'm going to take a right turn, that sort of thing. So the module that handles that uses physical dynamics, neural dynamics that are almost the opposite of our consciousness generating modules. So our consciousness generating modules has top down, bottom up resonance. So it has a resonance. It has two different kinds of neural activity, expectation, reality, and they resonate together. When we're doing motor control, when we're targeting, when we're driving, instead, what happens is there's a target. I'm going to drive there. And in the how module, the module responsible for driving the car, it mismatches it. It tries to drive the match to zero. From where I am now to the destination is trying to drive that to zero. So rather than resonating and having two things resonating, it's stronger. It's trying to drive these two fields to zero. So the fundamental dynamics in the process of driving, in the process of feeling the car becomes yourself. What's happening in your brain is almost the exact opposite of conscious experience and most social experiences as well. So very different dynamics.
Well, maybe a better example is VR. And again, this is coming at it from a more behavioral psychological perspective, but I think we could try to speculate as to the neural mechanisms at play. So, well, you could think about either VR, like you have goggles on and you're looking at a body that isn't your own, and after enough synchronicity, which I think might be the same type of resonance you're talking about with the behavior of this, you know, if you hit it, like if you feel a physical threat coming at this fake virtual body, or if you feel that you're about to step off of a fake cliff, you physically feel all these things. And I think that's related to this resonance topic, but it's fake. So I think that means that it's not just that we're only responding in this bottom up way to sensory input. We seem to be able to abstract that out to even a virtual environment. And the social environment representing social hierarchy, it's kind of like a virtual environment in that sense.
Yeah, social hierarchy is certainly a virtual environment. Yes, I would agree with that because it only exists in our imagination. There's
Huh.
no physical objective truth to the hierarchy other than what's in the community's minds in terms of the
So
attitudes.
to tie this back to autism, I have a few questions about that because this level 4 supermind that you referred to, I mean,
Yes.
I had my doubts even to say that it's only unique to humans, but even if we say it's only unique to humans, it seems even more difficult to go further and to say only a subset of humans that are not autistic. And I don't even think it's the idea that some humans lack that bothers me. It's more like what is the hard barrier between autistic and non-autistic, or between having access to this social supermind or not? Because I just can't help but imagine it like there must be gradations.
So we have all this supermind circuitry built into our brain, all this social circuitry. Um, Most prominently language circuitry for talking and for listening to others and having discussions and debates and trying to persuade others and trick others. We got lots of circuitry for that. So how does it all work? So it starts out with orientation, social orientation. In order to talk to somebody, in order to have a social experience, first we need to recognize there's a person. I'm going to orient and interact with this person. So that starts in our Y module, our emotion module. Our Y module is designed to have conscious feelings, to evaluate events, people, circumstances, and say, this is good, this is bad, I should do this, I'm in love, I'm in hate, this is what I'll do. But this module, the emotion module, the Y module, is also responsible for making other people seem interesting, for making other people seem important. In the human brain, the Y module looks around. If it sees a person, it says, that person is interesting. Pay attention to them. This is the difference between autistic and non-autistic people. If a non-autistic person walks into a room and there's a book, a bell, a candle, and a stranger, a non-autistic person will always orient on the stranger, almost always orient on the stranger. The stranger will pop out. It just seemed like the most important thing in the room, naturally, automatically, instinctively. If an autistic person walks in the room, they might look at the book or the bell or the candle just as easily, just as often as they look at the person. Why? It's because the Y module is not painting other humans as special. It's not giving special emotional feeling, emotional highlights, and emotional spotlight to other people. This is the difference. Now, because autists lack this spotlight, it creates a whole cascade, or rather, prevents a cascade of social activity from happening. In a healthy person, a non-autistic person, the Y module orients on the person. The next thing that happens is eye gaze. You look them in the eye, you orient on their eyes. This is a deep, deep ancient circuitry, goes all the way down to the fish, all the way down to the oldest vertebrates, eye gazing circuitries among all the vertebrates. Very powerful. Eye gazing is a platform for neural resonance between two different minds. Once you have eye gaze, now it's possible to send mental messages back and forth. From there, in humans, there's all kinds of basic social mechanisms. There's pointing, there's following gaze. I see you looking over there. I'm going to look where you're looking. You're pointing at that apple. I see that you're pointing at the apple. And then there's shared tutoring. You might show me how to carve an apple. You'll hold the apple in front of me. You carve it. I pay attention. Um, Primates can't do shared tutoring. They have shared gaze. They can look at the same thing, but the shared tutoring is something that only we have. And from there, there's gestures. You look at the other person's gestures and you can understand the gestures. And then on top of that is language. We have all this circuitry, humans do, all this supermind circuitry for gesture understanding, for language understanding, for gaze following, for pointing following. But all of that is triggered by orienting towards another person. So autistic people don't orient towards other people. So none of that activity gets triggered. Autistic brains can do all that stuff. We have social circuitry. It just never gets activated. We end up focusing on things other than people instead. We end up focusing on the book or the bell or the candle instead of people. And so we don't learn about social norms. We don't learn how to talk. We don't learn to talk well. We don't learn uh, uh, things like dating, things like having friends, things like holding a job. All of that stuff, comes from having that stack of social circuitry, this super mind dynamics activated, and they just don't get activated
Mhm.
in autistic brains.
So I'm with you that perhaps it's less natural to activate, but as you said, the computations can be done, and
Yes.
it seems like that's happened to you. Maybe it's a steeper learning curve, but it doesn't seem like you've struggled with those social things that you mentioned and professional things.
Oh no, I struggle
Well,
tremendously.
struggled,
I
but
struggle.
not
Yeah.
struggled versus complete inability. It seems like you've achieved them, however great the difficulty, and you know, just socially thinking about about how great a storyteller you are. And I can't see the eye contact directly, but it looks like you're certainly making eye contact with the camera.
Yeah, well, I've learned all this. I'm terrible naturally. I mean, I got kicked out of 5 different colleges, and I can't hold down a job with an office or a boss. It's just these are impossible things for me because of my autism. But I learned all this. I spent my life trying to figure out autism. So, that was one of my things I spent my life on. I figured it out. I'm explaining it.
Uh-huh.
So, yeah, I understand the neural dynamics of autism now after a lifetime, but it was a lifetime of pain and suffering. It's
Uh-huh.
awful stuff.
Yeah, so we we were talking earlier off camera about how I have some social difficulties, and I don't believe I'm autistic, and but many people, even peers of mine within a psychology department, clinicians, have thought so. So there's enough signal there that I think there must be something there. But the way that you speak in fairly binary terms, like you can or can't do this, well, I think if it's a matter of can't, then absolutely I'm not. But if it's a matter of you struggle and you struggle perhaps more so, but you can learn it, then sure, that sounds reasonable. But then I think, why is it not just an individual difference like we might talk about extroversion or agreeableness? Why is it this categorical label you're using?
It's a very specific neural deficit in the Y module. That's autism. It's not a spectrum. There's not lots of possible cause. Let me back up for a second. So, the autistic experience, all of what we consider to be autism, always arises from this defect in the Y module, from an inability to naturally and automatically orient on other people. Now, there's many biological causes of that problem. There's not one cause of this autistic deficit. Anything that would cause a brain to focus, uh, to not automatically focus on other people would cause this. So you could have too much of an enzyme or too little of an enzyme. You could have too much wiring or too little wiring. You could have too many receptors or too few receptors. So there's all kinds of things that would cause this neural deficit, but the neural deficit that causes autism is a deficit in the Y module. How it plays out in each person is different because how that deficit influences all the dynamics of the brain depends on the individual brain. So there's as wide a diversity of personalities of autistic people as there is in the general population. Autistic people have a single neural deficit in one part of their brain, but how that plays out, whether they're severely autistic, whether the autism, limits them in profound ways, or whether they're able to function, in society most of the time. How that plays out depends on how everything else in the brain is wired in that particular individual. It's not based on the specific deficit. The deficit itself is always the same. I mean, the deficit might be worse or better, more or less severe. Might be even harder to orient in other people, in some people's brains than others, but it's always to do with this deficit in the Y module, this
Mhm.
orienting deficit.
So thinking again about split brain confabulation as an analogy, again, you tell someone to pick up an object with their left hand, so right hemisphere is controlling that. Left brain is split, left brain controls language. You ask them why, and they'll give you a different reason. So it's confabulating. Now, when I think
Yes.
of your analogy of an autistic person walks into the room, there's a bunch of interesting objects, and there's a stranger, you're going to orient towards the interesting objects rather than the stranger. Knowing myself, that would probably happen, but I don't think it's that I wouldn't register the stranger. Often what'll happen is there's just this form of social anxiety aversion, like stranger danger, or I don't want to bother them, or, it's like momentarily considered, but then I'll orient towards the other objects. So that could mean two things. It could mean it's just a general social anxiety, it's something else completely than what you're talking about. It could also mean it is what you're talking about, but the social anxiety is akin to the confabulation in the split brain patient, like coming up with other reasons that you wouldn't immediately register with this person.
I think it's that. So if you're registering the person, and then you're feeling social feelings. Oh, I don't want to bother them. It might be rude. If you immediately have a social feeling, a social thought about it, then I would say that you're likely not autistic. That ultimately, autism is an attention affecting mechanism. It's an orienting mechanism. It's affecting what you're paying attention to. So if you are aware, if you're paying attention to the stranger and then going on to something else, or then having, oh, I don't want to bother them. I don't know them. Maybe I shouldn't go up to. If you're having thoughts like that, then you've oriented on them and then getting into your own social circuitry. So yeah, that's a strong clue you're not autistic.
Uh-huh. And what would it look like when you are, say, having to do it very intentionally as opposed to automatically, but thinking about social norms and thinking about, well, would this be polite? Would it be rude? Like rather than doing it in an automatic way, doing it in a very cognitive way that might be more demanding and more stressful. I noticed that. I've heard from autistic people, they also experience that, but it sounds like you're saying that this could be similar symptom, but different mechanisms.
Yes. So I think in autistic people, our social deficits are because we never paid attention in the right ways and at the right times to learning social norms, how to behave in unstructured situations. That's what autistic people have the most trouble with. If there's a purpose situation, like a basketball game, we got to play basketball, we got to score the basket. That's a social situation, but we know what the goal is. That's something we can engage in. But if it's like cocktail party chit chat, where there's no clear goal, it's just open ended. That's where um, autistic
Mhm.
people struggle because we don't know what to focus on. It sounds like for you, you're at the next level. Like you're aware of the people, there they are. And you're there and you're aware that there's social norms, but what's the best way to behave and act? So it sounds to me you're having social difficulties, but you're not having difficulty with
Uh-huh.
orienting and paying attention social.
It's tough for me. It's right on the edge because I resonate with some things you're saying and not others, which again is why I think most of my peers who have used this label, well, they're coming at it from the spectrum perspective and they're using terms like Asperger's where say you're more high functioning and maybe you can learn these mechanisms by brute force and even just in way of speaking, like yes, you've said it's been a painful lifetime of having to learn it. But still, I look at you and I think, hey, you're outperforming me socially here.
Well, that's very, very kind of you. And truly, I take that to heart. That's very nice of you to say. But I've had a lifetime to work on it. I cared about it. You know,
Hmm.
it helps to be aware of the deficit, as you are. I mean, so Adam, I see you're very aware of it, and you're doing things like this podcast, and you're thinking a lot about it. When you get to be my age, I guarantee you're going to be better. So take heart. It just takes effort and time. I'd say, but where you are at your age, you're further along than I was at your age.
Oh, thank you, Ogi. Uh, this could be an
Truly,
interesting segue to you said that there are specific reasons related to this specific social deficit that autistic people may be more interested in gender as you are. I mean, that was one of the little clues for me because I seem interested at almost to a fixation point that seems to cause some social difficulties, like peers look at you like you're weird. You're going to have some level of that during a PhD program to any degree. Like you're going to be hyper obsessive about this topic that you're spending years on working a dissertation on. But I'm comparing myself to other PhD students, and they still think that I'm obsessive or that I'm interested in more unacceptable topics like the nuances of sex and gender and its paraphilias. So we have that interest in common. Again, possibly due to different mechanisms, but what is the autistic perspective that might make people more interested in these either gendered or just more
sure.
generally social inappropriate topics?
So one of the most basic kinds of social activity and social thinking that is triggered in this social cascade by the Y module is sexual behavior, sexual norms, uh, sexual interests, all of that. uh, requires us first to orient to other people, shared gaze, uh, shared experience, communication, language. Then we can start learning about how we relate to one another sexually, how to express sexual interests, how sexual dynamics work. In autistic people, because we don't have that social orientation, we don't pay attention to the things that the brain's expecting to help us build up our sexual interests and sexual identity uh, in the way that was designed by evolution. I would never say there's right or wrong about sexual interests and sexual behavior. The mind is so complicated and it's designed to have variations throughout it. So the idea that there is a normal or typical or average sexuality wrong just doesn't make sense from an evolutionary point of view, doesn't make sense from a neural point of view. Um, we're designed as a species, we're designed to have sexuality as a species. We're designed so that we have individual variation in our sexual interests, in our sexual behaviors. This is part of the design. It makes humanity more resilient and stronger and more adaptive as a result. But why do those of us with social issues like autism, and it sounds like Adam, you have some social issues that may not be autism. Yeah, if sex is designed, we're designed to orient it in a certain way. Men differently than women. Men sexual orient different sexually than women. Men orient very visually. Men are designed to look at things. Women are more conversational. They're designed to talk things over and think things over in a different way. But again, those gender-based orientation mechanisms, guys orient on visuals, women orient on conversation and discussion and psychology. Um, if those don't get set up properly with orientation mechanisms and shared experience mechanisms, then they can end up being more idiosyncratic and quirky, which is what happens to autistic people. We don't go through the normal socialization process of learning about sex. So our brains can end up focusing on just about anything. Just as this, just as when we walk in a room, we might focus on that bell, book, or Kindle instead of the person. Sexually, and in terms of our gender identity, we might focus on other aspects of sex or gender that just seem more salient to us because our orientation mechanism uh, uh, is operating differently.
But that makes sense in terms of maybe atypical sexual or gender identity or presentation or behavior. But you also mentioned the fixation itself, like a curiosity with it. And, well, thinking about it, I guess almost in more Bayesian terms, I know you don't like that so much, but that it's because it's socially taboo and talked about overtly less, it just means it's untapped potential. Like there's weaker priors on it. So you're going to get greater prediction error, which with it comes perhaps greater dopamine release, just greater opportunity for learning generally. So in principle, it's not anything unique about sex, but it's just how starved we are for if you're trying to build a mental model of the world, and most people build that module unconsciously, that you're going to go out of your way to find the more novel input at the cost of triggering other people or be seen as
Yeah.
insensitive.
Here's another way of looking at it that matches what you just said. Sex is inherently a high energy stimulus. It provokes intense emotion in everyone. It shows somebody a naked picture and emotions, good, bad, fear, intensity, desire. Strong emotions are always going to be provoked by sexual stimuli. And the brain knows this. And so the brain has worked all these kinds of social circuitry and sexual circuitry systems to constrain the male sexual brain, to constrain the female sexual brain, to only focus on certain aspects of these high energy stimuli. But if you don't socialize properly, then these high energy stimuli can go in our brain in a different way. And then they can become fixations and obsessions because exactly like you said, it's very interesting. It's hard to get information, and the information is so important and so valuable and so emotional. Yeah, so it's a special category of stimulus. very, very reactive. It just generates emotional energy so easily. Yeah. And so if you don't have, we have all these millions of years of evolution to just kind of manage the intensity of the sex. But if that doesn't get set up right, like it doesn't in you and I, yeah, then we can become, pretty fixated on the energy of it.
Hmm.
Yeah.
Is this gender difference of men being more visual and women being more verbal related to the sex difference in autism, where if women are more verbally skilled and that's inherently social, that you see less autism? Or do you think that neurologically it's a similar base rate and just for other sociocultural reasons it's misdiagnosed in females?
Let me separate. I think there was two questions there. So first, I think in terms of the difference between men and women, autistic men and women in our sexual development, it's confusing for both of us. It's confusing for men and women. Women are more conversational, verbal, more psychological. Men are more visual. But in both of those cases, it's got to get set up properly through the orientation mechanism, which doesn't work for either of us. So male autists and female autists struggle equally to develop sexual identities. It's for both of us. I mean, we're developing different sexual identities biologically and socially. There's biological pressures, there's social pressures for women to be different sexually than men, but we both struggle to develop the way we're supposed to if you have autism. So that's the first question. Now, your second question, repeat what you asked. There was another question about
Well,
women.
more men are autistic than women, at least diagnosed, more boys than girls. Is that
I,
for
we,
neurobiological reasons or
we don't
just
know. I, it's historical reasons. I, I wrote about this extensively in my blog. I don't want to waste time here, but the history of autism diagnosis is terrible. It's an embarrassment. We should all be embarrassed. The DSM, the Diagnostic and Statistical Manual number 5, it's autism diagnosis is junk. It's nonsense. It's rooted in Freud. It's rooted in 100-year-old Freudian nonsense, and it's never been changed. It's never been updated. It's never been grounded in biology or neuroscience. So we do not know the relative prevalence of autism in men and women. We just don't know this. I know tons of autistic women personally, and I don't see any reason. I can't think of a biological reason why there should be more or less um, autistic men or women. Historically, it was discovered in men, and there was some nonsense theories in the 1940s that autism was a masculinization of the brain. This was a theory proposed when we knew nothing about neuroscience, and the people that proposed it knew nothing about neuroscience. It was completely cultural. Um, Men looking around at what men were doing in the 1940s, and they thought, oh, this autism must be just extra maleness. And that got stuck in academia. And so all the way till now, there's this notion that autism is somehow more active in males or it's inherently male. No, this is junk. This is junk dated to Asperger's. Actually, a German psychologist working in the 30s and 40s. He had the idea that he knew nothing about the brain. He's not looking in the brain. He does not doing neurodynamics. He's just looking at behavior. And he thought, oh, autist behavior just looks male to me. So maybe it's due to a male, masculine in the brain. And that's why there's more boys diagnosed with autistic, not
Hmm.
for any
do you think
medical
there could
reason.
be any connection to the sex differences in sexual desire that you talk about in A Billion Wicked Thoughts, where again, if women prefer more elaborated social, verbal fantasies, like things that have context related to dominance and prestige, just things that aren't so much immediately what are the characteristics, the physical characteristics of the body in front of you, that seems really like it's tapping into this social pathway much more so. So if men's sexual desire is more direct and visual, I just wonder if that could be an indirect mechanism that could mean autistic traits are more male-like.
I think autistic women uh, probably suffer a bit more than men. I don't like comparing suffering and who's got the shorter end of the stick in general, but because exactly like you just said, women's sexual development and gender identity is more rooted in social dynamics than the male sexual identity. Um, you know, women's notion of being attractive to others is much more social, and what women find attractive, like whether a woman finds a man attractive, is influenced by the opinions of other women. If a lot of women find a guy attractive, he becomes more attractive to a woman. This doesn't play out with men. Just because your buddy finds somebody attractive or less attractive isn't going to influence what you find attractive or less attractive very much. Um, but because women's sexual identity, gender identity is more rooted in these social dynamics, and autism disrupts that, I think they probably experience a more difficult time. It's difficult for all of us. So I, I don't like comparing it too much, but it does seem that women, have a bit of a harder time, sexually and socially because they both feel more of the social expectation. Certainly, they're getting more social feedback in their community that they should be more social. That say an unsocial man gets less. He'll get some feedback, but less feedback than a woman does for that. And also because a man's sexual identity, is more compartmentalized, more individualized, more isolated. He doesn't feel quite as strongly um, the lack of ability to attract mates. A woman who can't attract mates, I think, feels it a little more strongly. Though it sucks for all of us who have difficulty with
Mhm.
that.
Oh, we've talked about how autistic people could experience more difficulty in relation to typical sexual norms, but experientially, would you say there are any differences? Like, well, you mentioned you walk into a room, there's the social stimuli, the other appetizing stimuli, you might immediately orient towards those, but it's not like your sex drive is impaired. So that seems to be
Yeah,
different, but then I wonder how those two would interact when you have normal active sex drive. Like, so forget about when things are socially ambiguous and you could choose or not to choose to respond. But when you are orienting towards sexual stimuli, are there any differences there?
I think, um, and there's not data on this. So this is a prediction based on the neurodynamics of autism and the neurodynamics of sexuality, which I've studied and learned, written books about. So there's a prediction not rooted in data. I think autistic people, because we don't orient properly, we have more confusion about our own gender identity. That is, men, male sexual brains are designed to learn to orient on visual stuff. Female sexual brains are designed to orient on communication, psychology, social details more than visual details. But if you don't orient on either to begin with, then both are up for grabs. That is, our brain is designed to be male or female. I mean, we all have male circuitry and female circuitry. We're born with it. It's just the developmental process decides what gets activated through things like hormone release and things like this. And orienting helps that process of releasing hormones and knowing what to do. So if you're autistic and if you're a guy and you're not orienting visually, you have an increased chance of orienting towards the stuff that women are orienting on, or vice versa. If you're a female autistic and you're not orienting properly on either one, you might end up orienting on the male stuff, on the visual stuff. Both are up for grabs depending on the architecture of your brain. You might orient on a specific thing. You might become obsessed with a body part. You might become obsessed with a texture, leather or plastic or lace. All humans can become sexually fixated on any object. That's open to all of us. But I suspect, again, a prediction that autistic people are going to have more interest in specific objects or textures or body parts or things. We're going to obsess about some sexual element, some specific sexual thing, probably more likely, and also more likely to have just plain gender confusion. Am I orienting towards the visual or towards social, psychological? Am I a boy or a girl? That fundamental question, I think, is more unsettled because we can orient on either one.
In my research on sex hormones and puberty and brain development, I've gotten interested in the effects of puberty blockers and hormone replacement. Now, a lot of this is because the basic neuroendocrine theory is based on experimental animal research where you do block or manipulate these hormone levels. But then the natural question is, how does that generalize to humans? And before thinking about gender affirming care, which has only been in use for the past couple decades, there have been clinical endocrinology studies on people with various intersex populations, which usually are rooted in a prenatal hormone imbalance, whether it's in the hormone itself or in the way that the receptors function. And these sex differences that we're talking about, neurologically and personality wise, many of them seem rooted in prenatal androgen exposure in particular. But I think what's led to this interest for me is the interesting philosophical problem and social problem of fuzzy borders. And I think this is why this issue has become so politicized, thinking about policy surrounding women's protected spaces like sports, bathrooms, prisons, because, I mean, putting aside for the moment people with gender dysphoria and this possibility that you could be born into the wrong body, even just thinking about intersex people that don't neatly fall into one of two categories, that's an interesting problem. And this is another place where, okay, we've concluded it's not autistic per se, but when I tend to have a fixation, it's often on these controversial issues that are so polarized and tribalized. And it's fundamentally a problem of taking a complex, continuous underlying scientific reality and trying to put some categorical decision on it. You see the exact
Yeah.
same thing with abortion. It's related to this consciousness discussion. At what point does consciousness emerge? Well, we could take the most liberal view and say even an amoeba is conscious because of the molecular dynamics going on. No, you were saying that earlier.
No, the consciousness, any third run minds with bottom up, top down resonance. So no single cell creatures conscious, no invertebrates. Conscious,
Or did you say it was
uh,
performing computations and that's what I
it's
conflated with
thinking. Yeah, yeah,
consciousness?
yeah. Thinking,
Yeah.
thinking. It's thinking.
Uh-huh.
It's perceiving. It's deciding. It's remembering. It's not experiencing. Yeah.
Mhm.
You need. You asked, how do you know if a fetus or embryo is conscious? If there's top down, bottom up resonance, that's the physical embodiment of the conscious experience. So there's a very
Uh-huh.
it's a very precise biomarker of consciousness, and we can even measure the brain waves that come out of that. So it
Uh-huh.
is possible to identify that moment of consciousness, but even then, those early moments of consciousness, what are they? You know,
Mhm.
then you get some gradation, but you can say for sure, if there's no resonance, then there's no experience, there's no awareness, there's no consciousness, there's no
Mhm.
suffering. So yeah, so we don't only vertebrates, backbone animals, and maybe squids and octopi have consciousness.
Mhm.
I'm not sure about squid and octopus. They might have developed a third level of thinking, modular thinking, but I haven't spent enough time on their biology
Mhm.
to know for sure.
So all of this continuous complexity, but then wanting with language and with policy and decision making, trying to put some sharp cutoff on it. Those are the interests that fascinate me most. That's what drew me to
Yeah.
development. Same thing with adolescent development. You get not only sexual development, and it's a question of is that a categorical onset or a continuous onset? Does it interact with the care system, with other sex hormones, with oxytocin? That those are all fascinating open questions for me. You also get problems in juvenile justice, like an 18-year-old, well, your brain's not even done developing then. But even if we were to say the policy was now 25, well, there's individual differences in brain development and brain
Yes, there
age.
are.
So again, you have this cutoff problem. It also seems to connect with this deep signal detection theory because you're always going to have false positives, false negatives. That's another thing I like about the information processing view. Maybe that doesn't apply at the neural level, but it certainly applies at the social level.
I agree with you that the big challenge and the big fun is taking complicated, nuanced, scientific continuums, and then finding a way to create categories, distinct decisions. So, like exactly like you're discussing with gender affirming hormones and when to do them and whether to do them. That I agree. Those are big, interesting challenges. Though those fall into the the realm of politics and ethics, maybe not necessarily science when you're
Mhm.
trying to decide the best decision, categorical decision to make when the underlying phenomenon itself is messy and
Right.
not so discreet.
There's
So
definitely scientific. Go ahead.
what's the thing that you're interested in? That you're alluding to some interests that you have.
Mhm. So there's a few things. Part of it is what is the rational policy decision or even just social consensus that we should come to issues on this? Like, what is gender? Is it fundamentally binary? Like, mostly, but there are going to be exceptions, and you can't come up with a neat definition because if you look into these clinical intersex populations, any sex characteristic that you can think of, there's often going to be one niche population of people that have all other sex typical characteristics, but lacking that one, even down to the chromosome level. So this was fascinating to me to learn about that. I figured that it was more encoded in our genes, these sex characteristics that we develop, but it seems to be more hormone driven. So that means you can get rare populations of people. This happened in the recent Summer Olympics women's boxing competition, where one of the female competitors assigned female at birth and had female phenotypes, but male typical hormone levels and a Y chromosome. So the I don't think this was conclusively proven, but what I've seen discussion about it online was there's this one condition called 5 alpha reductase deficiency, which is an enzyme necessary to convert testosterone to DHT, which constructs the penis and scrotum. And when you think about how the genitals develop, it is on this spectrum like trait where blank slate is female and androgens, not just testosterone, but hormones like DHT, construct the penis. And this is also why you can get in some intersex populations like CAH, which I've published a couple studies on, you have females with male typical testosterone levels and DHT and other androgens. And as a result of that, they can have ambiguous genitalia. And it really does take on this spectrum, like a dose response relationship, more testosterone, more male hormones, more masculinization of genitalia. So the clitoris would grow out into the penis, the labia would grow out into what would fuse as scrotum. But if you halt that process at an intermediate hormone level, whether it's females with e- excess but not reaching male level androgens, or whether it's males with a lack of it, well, one more mild form of lack could be uh, underdeveloped but still functional micropenis. And pushing even below that, you could again get this sort of ambiguous genitalia. These are very, very rare conditions, but still, it's more philosophically, it opens up this question of this isn't as binary as we thought. And I'm not coming at that with any real political perspective other than insofar as it influences policy on gender and gender affirming care. And then separately, thinking about gender transition in minors, well, there's the neuroscientific question of how do gender affirming care hormones influence brain development, because we know that puberty is a sensitive period for brain development that's expectant of different sex hormone inputs. And then the other thing that this reminded me of, what you just said about autistic people may have more confusion with their gender identity because gender identity in this social sense is really just a form of social learning. And I don't know if there have been systematic studies on this, but at the very least, there's a lot of informal discussion of a plurality of anecdotes from these gender clinics, which starts to become data. Again, I don't know if it's been published and peer reviewed, but I've seen enough anecdotal data from gender clinics that autistic teenage girls in particular are more likely to experience gender dysphoria, which makes sense given everything you've told me. So that to me is another issue because then you could think there's gender dysphoria in the clinical sense that's child onset, might be driven by prenatal hormone imbalances, might fall into this more ambiguous intersex category. And then there's later adolescent onset gender dysphoria, which could follow similar mechanisms or could follow separate social mechanisms, perhaps just as a result of identity confusion. And if that's the case, autistic people seem more likely, and perhaps people with other body dysmorphia or social difficulties generally. This is all open questions, but I think questioning that is important. But because it's so overlapped with these political controversies, it makes it difficult to address those questions scientifically.
I believe I agree, or I what you say, everything you just said jives with what I think and believe uh, too. I, the only thing I would say is that um, be careful of emphasizing the hormones. Hormones have a big and obvious effect. You were just describing some of the effects, and it has physical effects. And hormones are easy to study. They're strict. You can measure them. We understand them. That sort of thing. And when the brain, you're always suspicious of stuff that's kind of like too easy to study things. Like autism is creating gender dysphoria without any kind of hormone imbalance. Let's be very clear about that. That if you have disruptions to social orienting mechanisms, you can produce all kinds of sexual dysfunction and gender dysfunction without altering hormones. And certainly not by, it's not being, these changes, these issues are not being driven by hormone imbalances. There's lots of ways to create gender issues, sexual issues that don't involve
Right.
hormone
That's
medication. That's
that's
all.
the idea, and
Yeah,
that's the research question for me, because if you're investigating the etiology of gender dysphoria, I don't think it's a single population of people or children
yeah.
experiencing it.
Not at all.
And
Right.
if there's an autistic person or just anyone experiencing it due to more social reasons, they're unlikely to benefit from any sort of hormonal intervention. If anything, that could
Right.
make it worse.
Yes. That's where I was leading. It's sort of like there is this hormone mindset again, because we understand them, we can identify them, we know them biochemically. So there's a sense of competence, fake competence around it. And so it's like a hammer and a nail. Hormones, there's an autistic girl with gender dysphoria. Maybe we could try hormones. That's a bad approach because the underlying problem is not a hormone imbalance. It's a social orientation issue, which isn't going to be resolved by
Mhm.
hormones yet. So,
There's one last big topic I want to ask you about, Ogi. This is more of a meta science question. And your comment on hormones and understanding neuroendocrinology here, I think, is emblematic of this. So you speak with a sort of scientific confidence, like, we understand this very well. You understand this very well, neural networks and all of these dynamic mathematics of consciousness. And it's kind of jarring to me just because of how used to hedging language I am in academia. Now, I don't like it, but I'm wondering then, if you think the confidence is justified,
yes,
what where does the hedging come from? I don't know if it's a social thing that's pervasive
I,
amongst academia,
it
but it
is.
bothers me too.
It is. It's exactly what I just said. It's exactly how I started this dialogue. There's three kinds of math and statistics and information theory. Everybody studies, everybody's exposed to them, everybody learns them, everybody knows them. That's what they bring to the table. So I mean, this is going to happen to you. You're going to get your PhD. You're going to get a job, I imagine, as a professor. Let's just say you're going to get a job as a professor somewhere. You're going to start your research. You start your career. You've studied statistics or information theory. That's what you're going to do your research. Now, all of a sudden, you come across a whole different approach to the brain, totally different, all new math you haven't been exposed to, and it's hard as hell. This math, what are you going to do? Turn your back on the 20 years of learning and education you've had to get to this point and adopt somebody else's work? Because all the people you've been reading and citing and thinking about, they're no longer going to be relevant in this new world of dynamic math, and you're going to be citing and thinking about entirely new people. That is a huge social jump. This is professionally, people don't want to do it. This is what happens. Nobody gets exposed to the dynamic mind stuff as an undergrad or a grad student. Everybody's just put in these learning trenches that are focused on stats or information theory. And so you end up with these skills and knowledge, and the academic literature, and the people, and then you encounter something completely different. What are you going to do? Drop all that for something totally new? No. So this is the fundamental problem. So this guy, Steve Grossberg, starting in 1958, he worked out all the math for the brain. It's really complicated. It's really hard. It takes a long time to learn. It's not something you're going to learn in 6 months, and most people don't want to put in the effort. It is literally like Einstein's theory of relativity, all the math of quantum physics. It's there. It's done. It's worked out. It's well understood over 65 years. This is not like some new development, uncertain. That's why I have the confidence. It's sitting on 65 years, more than 1,000 papers, just tons and tons of research and data, interdisciplinary data, biochemistry, game theory, neurodynamics, social dynamics. It involves so much. This is not something small or uncertain or ambiguous. The opposition is uncertain and ambiguous, and that's where you find all the hedging because they haven't figured shit out. They don't know what's going on. That's why they hedge all the time.
Now, do you think this is an orthogonal scientific problem just on the nature of the data and whether it's probabilistic or not? Or do you think it's also the social dynamics that we've been talking about this whole time? Because, I noticed that even if it's a critical question, a lot of people at an academic talk, they'll feel a need to hedge it with, you know, great talk. Like they sugarcoat a lot instead of just being direct with the question. I tend to be more direct, where I experience some of the social difficulties that we've talked about. I hear that directness in your confidence, which I admire, but maybe there's enough social attunement and just this environment that I'm surrounded by to think,
Yeah.
wait, are we allowed to do that?
Let me be clear. There are uncertainties about the brain. There is a cutting edge where there are mysteries. It's just that edge is way higher than where most academics are these days. Stephen Grossberg pushed the edge there. So I have confidence about the things that have been worked out over decades. That's where the confidence is. And we're talking about the rest of the field is still dealing with things that have been worked out. Here is a perfect example. The Nobel Prize just awarded the past month um, to Hopfield uh, for his contributions to artificial intelligence. He developed uh, the reason he was awarded the Nobel Prize is because he supposedly developed something called a Hopfield net. And he got the Nobel Prize for this. And they explicitly said, pioneer of artificial intelligence, one of the first neural network algorithms, which is now being used everywhere, which is true. Hopfield stole it from Stephen Grossberg. Well documented, well known. Steve's out there right now telling everybody who listened and showing how it was stolen. I was working with Steve Grossberg in Yale at Boston University when this was playing out back in the 90s. Well established. Nobody ever imagined that this guy would get a Nobel Prize. Why did he get the Nobel Prize and not Steve Grossberg, who actually did the work, came up with the work that was stolen? Because Steve Grossberg's work is so confusing and complicated and nobody can understand it. What Hopfield did was take a tiny little piece of Steve's work, render it in a form that people could understand and use, and then it got used, and so he got the Nobel Prize for it. So this is a perfect microcosm of the state of neuroscience and mind science today. The guy that actually knows this stuff, unknown, unappreciated, just nobody wants to deal with his mountain of math. And instead, this guy stole a little bit of Steve. We're just going to give him the award. We understand it at least. We know what this tiny piece that Hopfield pulled out is. So yeah, that's the state of mind science. And students don't know any of this. They're just being taught the same wrong stuff, the same old, boring, wrong stuff that's been taught for 100 years now. And how do you find out about the true stuff? Yeah, it's hard to do.
Yeah, there's another form of social inference at play. I don't know if you experience this, but when I do a podcast like this, or I find someone saying with a lot of confidence, here's where mainstream science has gone wrong, and here's the real solution. There's a part of me that gets excited, and there's a part of me that gets really skeptical, especially when it's like, this science is too hard. So all of academia has just missed out and taken the easy way out. It almost sounds conspiratorial, and I'm not accusing you of that so much as reflecting on this is the first thought that comes to mind. And I think it must be one of this automatic social cognition things that it starts to seem, sufficiently out of sample, and the immediate affective consequence, if true, would be you experience a whole bunch of doubt that you want to hedge. So it's often easier, and I think this is why you get these snowball effects in academia where it's just like beyond a critical mass, people don't want to seriously doubt foundational knowledge, and it's easier to just arrive at the conclusion the dissenters are fringe.
So first, you're 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 right to have those feelings of doubt and skepticism and dubiousness. It's science. You should doubt. You should treat claims with skepticism. So that's science. That's great. I invite skepticism, doubt, bring it all. You should. It's science. You should doubt the hell out of everything. Obviously, I'm not afraid of the doubt. So bring it on. Um, and I think you've also hit the nail on the head. If you've spent a lot of time learning something, and then you encounter a view that, hey, what you've been learning is the wrong way to learn. Here's the right way. It creates powerful cognitive dissonance in academics, and it puts a decision to them. It's a choice, and it is not an easy choice. And you look around, well, all these other professors, all these others in my academic community think like me. They don't think, this other way, this, like Steve Grossberg thinks. So I can continue having my career and functioning in life and doing my stuff because there's a community to support me, and that's what ends up happening. If you look at the history, I know we're out of time here, and so I won't talk about it. On my Substack, ogiogas.substack.com, I've written about some of these histories. When you read the true history of mind science, here's the thing you mentioned. I'm sorry, you didn't say canonical mind science, but you were suggesting this. You look and you see this new alternative, perhaps like a dynamic approach, but then you just go back to the conventional approach. Here's the thing. What is the conventional approach to the brain? What is the standard understanding of the mind? What is the alternative to Steve Grossberg's dynamic framework for the mind? The statistical framework is not a unified theory by any means. It's not remotely. It's just a bunch of factoids about the brain. It doesn't cohere into anything integrated. The information theory perspective, also a bunch of factoids. It doesn't cohere into some unified account of the brain that explains all the parts of the brain. The dynamic math does. The dynamic math explains what's going on neurally, what's going on molecularly, what's going on modularly, what's going on cerebrally. It's got math for all the levels, and all the math works together. There's nothing, stats and information theory can't offer anything remotely close to that. So yeah, this is the state of mind science. It's an embarrassment. I mean, the more you learn about the truth of of our history, the more embarrassing it becomes. And like I said, the turning point was Freud. Freud had a chance to make, it's very simple. He had a choice to make mind science mathematical or non-mathematical. And he made the entire 20th century non-mathematical, and we've never really recovered. That's the situation we find ourselves in. And everybody's resisting learning the math because the math's so goddamn hard and unfamiliar. If we taught kids in high school the math of the mind the way we teach them physics, it's silly that we're teaching them physics, which they're probably never going to really use in a useful way. But if you learn some things about the mind, that's incredibly useful. But one day we'll start teaching mind math in high school instead of physics, and then more mind math in undergrads. And then there won't be this huge discrepancy between physics and mind science.
I'm pretty optimistic about convergence between psychoanalysis and mathematical neuroscience. And I also think it has something to do with large language models. Like, I mean, I'm still coming at this from statistical priors. This is how I've made this argument
Sure.
in the past. But what you're doing
Yeah.
in psychotherapy, like I don't, I mean, maybe it's a derailment just in terms of how much math he was actually publishing on, and how much overt discussion there was. But the project of psychoanalysis, to me, it still seems like it's operating on those basic principles. If you abstract narrative in this more mathematical way and think that we have this collection of modules And I think that that's why I like the LLMs, which there's a lot of interesting research overlapping between that and cognitive science and psychology that's on this frontier now in computational cognitive science. I think people are starting to realize, I mean, whether it's statistical or not, that there's information in repeated patterns, and that's probably why we see this modularic specialization in the brain. And it's also probably why you have these psychoanalytic insights of the unconscious mind or of something that, is deeply embedded within your past. I mean, again, this is why I come at it from a Bayesian perspective, because to me, talking about the past in a psychoanalytic way seems a lot like, unraveling your priors and getting to the core of it. I'm sure there could be a way to update that in a dynamical systems framework as well. But I like seeing, I think I see more of it because of this podcast, how much convergence there is across different interdisciplinary spaces. I just did one with a philosopher who wrote a book called Metamodernism, and this is his remedy to postmodernism. And the meta component, it's kind of related to this, like this idea that there are meta patterns that are biologically or computationally constraining of how human language and cognition ought to work. And that if we ground our philosophy, if the humanities within that, as opposed to a postmodern infinite possibility that's kind of unconstrained and kind of meaningless, then uh, you can start to see in this deeper mathematical way a reflection of human nature within our own art if you look at it in terms of analyzing these universal meta patterns.
Adam, I think you should keep exploring that direction. I mean, it all sounds, like a great direction for research and study and self development. So, just encourage you to keep going.
Thank you,
It
Ogi.
also
Thank you for your
that all
time.
sounds like a great lifetime research project.
Yeah. Thank you for your time and for the work that you do.
You too, Adam. Thank you so much for having me. Very pleasant conversation.